So the first law we're going to look at is Boyle's law. So Boyle's law says that gas volume is inversely proportional to the pressure applied to it. So that means that when one value goes up, the other value goes down or decreases. When the other value goes down, then the other goes up. So the greater the pressure, the less the volume, or the greater the volume, the less the pressure. So if we think about it in terms of a scuba tank, if you go down underneath the surface of the water, so about 10 meters of water is equivalent to an atmosphere. So the entire atmosphere of the gas above you on the earth is equal to like 10 meters of water. So as you go down with a scuba tank, the volume of the gas that you have in that tank becomes smaller and smaller and smaller. So you have less time to dive because the volume gets smaller. That means you have less air to breathe, or less gas volume to breathe. So the equation for Boyle's law is that pressure, the initial pressure times the initial volume, is going to be equivalent to the final pressure times the final volume. So if we look very simply here at this graph that shows an inversely proportional relationship, if we have pressure at 6 atmospheres and the volume is 2 liters, if we were to cut the pressure in half, that would double the volume. So half the pressure at 0.3 atmospheres would double the volume of 4 liters. So let's go ahead and just do a quick example using Boyle's law. So it says you have a sample of chlorine gas and it occupies a volume of 946 milliliters at a pressure of 726 millimeters of mercury. What is the pressure of the gas in millimeters of mercury if the volume is reduced at a constant temperature to 154 milliliters? Now this constant temperature is written in there so that we know that the temperature stays the same and isn't going to affect the pressure or the volume. We saw in the simulation in the last video that temperature is related to pressure and volume, so we'd have to keep it constant in here so we can just look at the relationship of pressure to volume. Now notice that the units are in milliliters and millimeters of mercury. That's fine. It's okay to have our units in something other than our SI unit as long as our units are consistent throughout the problem. So remember, pressure 1 and volume 1 is equal to pressure 2 times volume 2. So my initial pressure was 726 millimeters of mercury, and my initial volume was 946 milliliters. I want to know my pressure if my volume went down to 154 milliliters. All right, so let's just think about it conceptually and then let's look at the math. So we know that our volume has decreased, okay, by about a fifth. So what does that mean in terms of our pressure? Well, we know they're inversely proportional. So if the volume goes down, the pressure must go up, and by the same factor. So it should be almost 5 times as big. So let's go ahead and look. So we can algebraically solve this equation for P2. So all I've done is I've divided by V2 on both sides. Then I plug in my values, and I can see that the milliliters will cancel out. And so I'll be left with millimeters of mercury. And so I just take 726 times 946 and then divide by 154. And I get 4,460 millimeters of mercury. So we can see that the pressure did increase by a significant amount.